Hello class, this is Math 1220. Doug Schwartz here at the helm, and this is review for test number 2, which is going to happen on October 16th, which is Friday. So it's coming up pretty soon indeed, this Friday. Okay, so what stuff is going to be on this test? This test is going to cover everything after test 1. So library of functions. There were about, I don't know, 6 or 7 of those. We should have those memorized. Of course, you can use your notes, so that's okay. Transformations we should be familiar with. How to graph in stages, that means. Like, in other words, vertical shifts and horizontal shifts and reflections. Algebra of functions, like if you have 2 functions, do you know how to add them or subtract them or multiply or divide? Let's see. I'm trying to remember. Is compositional functions on this test? Can't remember. Piecewise defined functions, difference quotient, and quadratic functions. So I did 2 examples right here, and the other stuff I'm 99% sure I covered in past videos. So like for instance, the difference quotient. I did that video. I don't know why I did it out of order, but I did that one a while ago. So you can hunt that one down. It should be titled difference quotient. Okay, so let's look at this quadratic function right here. Given f of x equals 5x squared plus 23x plus 12. So notice it's a degree 2, so that means it's a quadratic function, which means its graph will make a parabola, and we should know that all parabolas have a vertex. And what do we want to do with this function right here? Oh, let's see. Let's find the intercepts, the vertex, what's the minimum of the function and maximum as well, and find the domain only, because to find the range you really need to graph it. Well, you know what, let's find the range too. Okay, so let's do the y-intercept first. It's always easy to find the y-intercept, easier than the x-intercept. You just let x equal 0. I even let that x equal 0. So f of 0 equals, then just plug in 0 for all x's. That's the definition of a y-intercept. So that's the first step right there. And let's do the math. 0 squared is 0. What's 5 times 0? 0 plus 0 plus 12, and doesn't that equal 12? Or you can write it as an ordered pair. We got to remember, intercepts are really points on the graph. So 0, comma 12. That's going to be a point on the y-axis. How do you find the x-intercept? To flip-flop, you let y equal 0 and solve for x. So a little bit harder to find the x-intercept. So what's the next thing to do if we want to solve for x? Factor next. That's the way to do it. So it's trial and error. Notice 5x times x does give you that 5x squared. What 2 numbers multiplies to 12? About positive 3 and positive 4, especially since that's a plus. I know these are going to be both pluses. And that works. You can use the FOIL method to see if it does, and it does work. And now the zero factor property. This one's tough to do in your head, so I did the scratch work over here. 5x plus 3 equals 0. And let's solve that for x. Subtract 3 from both sides. We get 5x equals negative 3, and then divide both sides by 5, and we get x equals negative 3/5. So that's one x-intercept. I wrote it as an ordered pair. And then this one you can tell by inspection, x is going to equal negative 4. So those are the 2 x-intercepts. Let's find the vertex. When you have a quadratic function in standard form, think of this idea. How do you find the x-coordinate of the vertex? This little formula. The x-coordinate of the vertex is negative b over 2a. And what is opposite b here? B is the coefficient of the x term. So what's that coefficient times negative 1? Negative 23. And then what's 2 times a? A is the coefficient of the x squared term. What's 2 times 5? 10. So that's what the x-coordinate of the vertex is. Do we know that trick for dividing with the power of 10? Since I'm dividing by 10, move that decimal point once to the left. So that's the same thing as negative 2.3. But you can leave it like this. Nothing wrong with that improper fraction. So we found just the x-coordinate of the vertex. Now we need to find the y-coordinate of the vertex. So all you do is you plug in whatever you got for the x-coordinate of the vertex, plug it in for all x's in the original function. And when we do that, we're going to have this. And then I made this function up. It's a little, on a test it won't be this complicated, but that's okay to see the hard stuff. How do you square a fraction? You square the numerator and you square the denominator. So, and notice a negative squared is a positive. So we get this, And what's a positive 23 times a negative 23 tenths? Isn't the sign negative? So you get the sign for free. And just multiply 23 times negative 23, you get 529 there, or negative 529. And this is just 10, because 23 over 1, what's 1 times 10? 10. Okay, plus 12. And what's 5 times this fraction? Again, just multiply the numerator by that 5. So you get that. And then I wanted a common denominator, so I multiplied top and bottom by 10. So what's 529 times 10? You just add a 0 to it. Okay, and then what's another name for 12 with the common denominator of 100 as the denominator? Just multiply the numerator by 100. 12 times 100 is 1200. And then let's simplify that. Notice when you're adding up like fractions, you keep the same denominator and add up the numerators. And when you add up those three numbers, you get that. So that's the y-coordinate of the vertex. So there's the vertex right there. By the way, this thing, if you divide this by 100, just move the decimal point, which is always assumed to be at the right of the number, 2 places to the left. So that's where that negative 14.45 comes from. So we found the vertex. We know this parabola opens upward since a is positive. Right? Here's our function. A is the coefficient of the x-squared term. If a is positive, the parabola opens upward. If it's negative, the parabola opens downward. So since it opens upward, the parabola opens upward, so doesn't that imply the vertex is a minimum? Isn't that the smallest point, especially the y-coordinate? Isn't that going to be the lowest y-coordinate for that point, the vertex? Yes. So that's why we have a minimum. And the minimum is just going to be the y-coordinate of the vertex. So say the minimum is negative 14.45. That's the best way to do it. If it said, where does the minimum occur at? Then you can write it occurs at x equals negative 2.3. But here we're just asking what's the minimum. So all you have to do is say, you just say the minimum is negative 14.45, the y-coordinate of the vertex. You don't have to even write y equals. Just say the minimum is negative 14.45. What's the maximum? Notice if a parabola opens upward, don't these, there's like little arrows here I should have drawn. It goes up forever, and that means it's going toward infinity, so that means that there is no maximum, because we want a real number for these answers of minimum and maximum. So there is no maximum, so it's a little tricky. Okay, what's the domain of this parabola going to be? Domain of all parabolas is all real numbers. What's the range? Range is always a little tougher. You got to look at the graph. And I did draw a rough sketch of the graph. These were our two x-intercepts, right? Remember here, the intercepts, negative 350 and negative 40. So there, and the y-intercept, we had a 0, 12. The vertex, we had as negative 2.3, comma, negative 14.45. So that's a good rough sketch of the parabola. So what's the range going to be? Think of extremes. The range is the y-axis. What's the lowest y-coordinate? I should have labeled the vertex. But isn't the y-coordinate of the vertex negative 14.45? So the range is going to be this. Negative 14.45 to infinity. Use a square bracket for this negative 14.45 because that is a point on the graph. And isn't this going up forever, the parabola, so that's why it's going toward infinity. Okay, let's try another problem. Library of functions. Here's just a brief sampling of some of them. I think there's about 7 of them. Y equals the square root of x. It's nice to have that memorized. It looks like that. Notice none of the graph is over here on the negative part of the x-axis, because can you let x be a negative number? No, the square root of a negative number is not in the real number system. Notice the marriage of algebra and geometry. What does the absolute value of x look like? Y equals the absolute value of x. It looks like that. What about the reciprocal function? Y equals 1 over x. That looks like that, where you get these asymptotes. Y equals 0 is a horizontal asymptote. So these branches will never touch the x-axis, which is what the equation y equals 0. Remember, horizontal lines have the equation y equals a number. And then there's a vertical asymptote, x equals 0. So these branches will never touch the y-axis, which is the equation x equals 0. Remember, all vertical lines have an equation x equals a number. And doesn't that make sense? The vertical asymptote is super related to the domain. Can we let x equal 0? No, you can't divide by 0. Let's try this. Transformations. Graph in stages this function. Okay, so I'll do that right now. Start with the basic graph. So the basic graph, you should be able to tell it looks like this basic function. So I'm going to write y equals the absolute value of x. Y equals the absolute value of x. I like to label each graph, each stage, and that's this graph right there. I'll just label one key point, the vertex there. So if x is 0, what's the absolute value of 0? 0. Okay, now we only have two transformations here. A horizontal shift, because that's right inside the function, and this vertical shift, because isn't this -2 in right field? So that's a vertical shift. It doesn't matter which one you do first, although if you have a vertical shift, you can't go wrong always doing that last. So I'll do the horizontal shift next. So notice I'm going to label my second stage as y equals the absolute value of x plus 1. Notice I only do one transformation at a time. And what is this graph going to look like? It's going to look remarkably like the prior graph, except we're going to shift this graph 1 unit to the left. It's a little tricky, these horizontal shifts. It's the opposite of what you think. So let's draw the graph. Look how quick and easy we can do that. And then what is this ordered pair going to transform to over here? You know, don't do another table of values here. You don't need to. Just transform this ordered pair. 0, 0. Horizontal shifts affect previous x coordinates. So I got to subtract 1 from all previous x coordinates. So that becomes -1 and leave the y coordinate alone. So -1, 0. And if you want to check it out, it should work. Since it's a point on the graph, it should solve the function. If I let x be -1, what's -1 plus 1? 0. What's the absolute value of 0? 0. And sure enough, that's 0 for the y coordinate. So everything's groovy. And now one more stage to go. How about the whole enchilada now? The whole ball of wax. What is that graph going to look like? This is the beauty of transformations. You don't need to do a table of values. Just look at the prior graph. What is this graph going to look like? It's going to look remarkably like the prior graph, except we're going to drop it down 2 units. Vertical shifts affect the y-axis, or y-coordinates. So look how quickly we can graph this. I'm just going to drop that one down 2 units. Done! Done! Look how quick that was. And vertical shifts affect previous y coordinates. Vertical shifts are honest. That's a minus sign. That's why I drop down the graph. This says subtract 2 from all previous y coordinates. So here's the previous y coordinate, 0. What's 0 minus 2? -2. Leave the x coordinate the same. So -1, -2 is the new vertex. And let's figure out the domain and range now of the final graph. It's always just the final graph. They want to know the domain and range. What's the domain going to be? All real numbers. Doesn't this graph cover the entire x-axis? This branch goes up and to the right forever, so it covers that part of the x-axis. And this branch goes up and to the left forever, so it covers that part of the x-axis. So the domain's all real numbers, just like the parabola was all real numbers. What's the range? Think y coordinates with the range. See, the vertex is a key point. That's why I labeled that one. Isn't that the lowest point on the graph? The smallest y coordinate? And always go low to high with these intervals. And this is a point on the graph, so I am going to write the range as an interval notation 2 to infinity. That's what the range is. Does that make sense? Sure. I could also write the range as this. Y is greater than or equal to 2. Same thing. All right, folks, study hard for this test coming up on this Friday, October 16th, and I'll see you next time.